Okay, thanks for coming to this OpenShift Commons briefing about controlling chaos and microservices. My name is Steve Ross-Talbot. I'm from a company called Estefet, where I'm the CTO. And today what I want to do is talk about some of the challenges of building microservice architectures, some of the design choices that we face, and some of the new technology that's come to the fore in the last 2 or 3, maybe 4 years, that's starting to find real success in how we deliver microservices over a period of time and dealing with the chaos that often ensues. So what I'm going to do is walk you through some basic stuff at a high level, a bit of history, how do we get here, talk about an example which you can get from the Estafet GitHub, which is down in the bottom right corner, and you can run all of this stuff. It will deploy into a mini shift environment, so that's like OpenShift on a single box, and it will deploy into an Amazon cloud if you wish, if you've got the credentials, and everything should work just as you will see it here. I've got a few little video snippets of a demo that I recorded earlier, just to make the points. So I hope you all enjoy it. Sit back, relax, and let's see where we go. So the challenge really is that how do we make order of the chaos that ensues from when we start building microservices? Because if you're building small things and deploying them continuously, it's pretty hard to track everything. And as you go above 10 microservices, it starts to feel like this little icon here of strings intertwined. And what we really want is we want some kind of order. We need to unpick the threads in order to understand, particularly when things go wrong. And there are some pretty interesting cases of when things go wrong. There's a big bank recently, I won't mention their name. They went to a microservices architecture. They turned off their old J2E legacy style architecture, and the thing didn't work as they expected. So a lot of people weren't able to get money out of the bank, and this has caused a lot of consternation. And what I've heard fairly directly is that they've tried everything. They've tried Dynatrace, they've tried AppDynamics, they've tried every monitoring tool available on the planet. They've got Splunk, but it wasn't really giving them what they wanted. What they really needed was to understand the transactional trace through the distributed architecture. So A passes to B, passes to C, who passes to D and E, and then all that comes back. So trying to make that order from the chaos that ensues is essentially what Jaeger and OpenTracing gives us a shot at. As you'll see as we go through, this becomes ever more important in the world of microservices. So before I do that, I just want to talk a little bit about history. I'm pretty old by comparison to most of my colleagues. I'm much nearer the end of my career than the beginning. And I've seen a lot over the history of computer science. I wasn't quite there when Alan Turing was there, but I was born perhaps about 5 years after, alas, he died. So if we track back to the 1960s, which is kind of when I started really, it was a world replete with mainframes. Most people were doing COBOL jobs in commerce and monoliths. And we had a kind of pretty standard waterfall software development lifecycle. And the languages of choice right at the beginning of the 60s were Fortran and COBOL. Interestingly enough, Edgar Dijkstra always talks about COBOL in the sense that it was a shame it was ever born, because it's led to many bad habits. And then, of course, we get BASIC, and then the explosion of GoTo programming, which made it really hard to debug a single application, let alone many all talking to each other. And then the desire for structure comes in when we see Algol 60 initially, and then 58. And then we get really simple languages that come to the fore, like the C programming language that led to the rise of the Unix operating system. And of course, in the 1980s, we get towards PCs with the Macs coming out in force, and mini computers. We get Ethernet and this more distributed model of computing that involves sort of client server. And those of you that were around in the 80s and programming, I'm sure will remember all sorts of things like Corba and message buses and all of this stuff. And methodologies changed a little bit. We get SSADM, we get Jackson structured programming, various others. Smalltalk arrives and C++ arrives. Those in the Smalltalk community would probably eschew the C++ community as not being truly OO, because it was kind of like C on acid or steroids, however you want to look at it. Whereas Smalltalk was much more of a proper object-oriented language in the sense that rather than being fascinated by polymorphism, it was much more fascinated by interaction, which comes back in the world of microservices. So in the 2000s, things start to really hot up. There's a lot more changes in that 20 years. The birth of the web. The web now is actually, anyone that's a CIO has got to have a web strategy. W3C is starting to emit standards like there's no tomorrow, as is Oasis and all the others. We get the rise of grid and virtualization. Laptops are all over the shop and racks. And the birth of things like service-oriented architecture as an idiom, and really the birth of Agile as a generic delivery method, and Scrum alongside it. And we get additional languages, largely driven because of the web tier, with JavaScript and Python, because data and actually automating things, scripting becomes kind of an interesting place to be, because we're becoming more distributed. So control of the distributed plane that we're executing things on and delivering into becomes a little more tricky. So languages like Python come to the fore. So when we look at the 2010s and then to where we are now, 2018, we've got the birth of cloud, we've got microservices, and we've got things like SaaS, PaaS, and infrastructure as a service. So we've got the birth of platforms and as a service models, and we've got the birth of Lambda functions as well, which gets kind of interesting. And interestingly, in the methodology side of things, nothing much has changed. I mean, microservices you might consider to be to some extent a methodology, but really it's predicated on two things. One is agile delivery, and the other is this sort of boundless cloud-based execution that allows you to scale to internet size. Meanwhile, in the languages domain, we get the birth of Go. Oddly enough, OpenShift and Jaeger are both written in Go. And we get now, very recently, the birth of something like Rolang as a really, really good smart contracts language for blockchain, which may have other applications. So the world that we live in has got infinitely more complex, much harder to deal with in terms of being able to point to where your application is running. And pretty much all we can do is sort of look at the application as a distributed system in terms of its resource consumption, rather than semantically, what is it actually doing? What is it doing an international payment, and what are the constituent parts of doing such a transaction? So on the one side, it's become easy to deploy. We don't have to wait too long for an environment, but on the other side, it's become very tricky to manage the complexity that ensues because things are just much more connected. So microservices as an example. So if we talk now about an example to illustrate the concepts of distributed monitoring, generally when you do a microservices delivery, if you're coming in at the beginning, you're starting to gather story cards. So in the example that I'm going to show, our business domain is how do we manage project sprints, stories, tasks, and how do we look at the burn down? So you see a set of story cards. As a manager, I want to be able to see a burn down chart of my sprints. This is fairly typical, and we're using this example specifically because it's probably familiar to most of you that listen to this webcast. So the thing about the microservices, of course, is on the other side is we're looking for independence of deployability. So we don't want to have to deploy everything in one go. We want to be able to pick and choose what we upgrade, what we change, as and when we need to. And we don't really want to have loads of stage gates, so we want it more automated into production. We want to protect ourselves from change with service contracts. We want to decentralize decision-making as to who owns the sprints versus who owns the tasks versus who owns whichever microservice. And to do that, we would establish cross-functional teams that would include a product manager who represents the users, and we deliver this in an agile way. So this is just an example of 4 story cards that drove this particular example. So when we look at the example, we start to, you imagine you're in an inception, the first sort of week or two of a project's life. You might start jotting on the board, well, what are the fundamental business domain objects. So we might say, hey, look, we've got a project. Projects are made up of sprints. Sprints have stories, stories have tasks, and stories have acceptance criteria. So every time you have a sprint, there might be one or more stories. Each story may have several tasks, and they have a status, which for a story or a sprint might be whether it's been started, whether it's been completed, whether it's not started yet. And those become, if you like, the state behavior of the business domain model objects. So we might have something that looks very much akin to this. And as we start to sort of look at how we would actually build that as microservices, we'll see, first of all, how would you set it up? If you need that independence of deployability, and this is what OpenShift is particularly good at promoting, so it makes it easy to build these microservices. If we look at how to set that up in GitHub, you would actually establish a GitHub repository for each and every one of the microservices so that you have that independence. Because at the end of the day, OpenShift will work on the basis of the Git hooks. So when you commit any one of these, if I change the Estefet microservices Scrum API sprint microservice, independently of all the others, the Git hook would be registered with OpenShift and it would pick up the changes and automatically go through the CDCI pipeline so that you could see what was going on live as the thing starts to get deployed. So the project setup becomes quite important in terms of how you achieve the independence of deployability. If you get this wrong, then your independence of deployability will not be as high. So when you think about these microservices, these domain objects, and then the microservices that might represent this architecture shows how we've structured the project. So what we went for was a basic UI so that you could interact with the data. We've got a gateway that sort of hands off RESTful API requests and a potential discovery microservice that allows us to do searching over projects and sprints and tasks. And then we've got a range of microservices representing those business domain objects from the sprint board, the sprint, the task, the story, the project, and the burn downs. And then we've got a JBoss AMQP implementation, a message broker, that allows all of these things to communicate with each other. So at the gateway end, what's coming in is HTTP requests, and within the family of microservices that are collaborating, we may pass messages to inform one particular microservice of a state change in our microservice. So in this way, it becomes easier to carve up the architecture and understand who owns what data and who is interested in what data, which is a very different thing. And then at the bottom of this, we've got sort of some sort of database, which is Progress in our instance, and then they have all their own logical partitions, or they might have one database per microservice physically. And that's kind of how one might look at the microservices example. So the way that this works, as I said before, is that you end up writing, taking stuff from your Jira and end up writing your Java, your JavaScript, your Go, whatever language you're using for your microservices, committing that in the GitHub. And then your QA guys are writing SonarQube scripts and Cucumber scripts and Selenium scripts. And your DevOps guys writing the Ansible to actually implement, if you like, the life cycle of how you're going to do your build, deploy, test, validate, run, and life cycle from the point at which you start cutting code to the point at which it is deployed and runs in an environment. And all that gets into GitHub somehow. Ansible is responsible for, to some extent, orchestrating how different things get put into OpenShift and which particular containers or pods they go into. And the GitHub, once all that's established, the GitHub hooks are just used to enable source to image so that everything can run. So this is what we understand by DevOps automation. So in our OpenShift environment, whether it's Minishift or OpenShift full fat, shall we say, we've got a Jenkins pipeline for all of the integration tests. So this isn't just a small example that we're showing you. This has a full life cycle with all of the integration and the unit tests. And when you deploy it, you'll actually be able to see this. And of course, all of the microservices run in a Docker container within a pod, and there's this Ansible control over how the life cycle works into production. So what we're going to look at specifically is we don't have the JavaScript and Go stuff. We're going to concentrate on the Java, GitHub to Docker Ansible side, rather than look at all of the tests. Because if you just download this, you can see the tests running yourself and pop them out of the GitHub and see how they're constructed too. So if you go to the GitHub, you'll see Cucumber tests, you'll see some Selenium tests, and so on and so forth. So what I'm going to show you first is a small movie of just how we get this project up and running. So this small movie, if I press the play, so what you've got here is what we're seeing is one of the pods being deployed. So this is the Ansible script to deploy, and you can see loads of stuff going up on the screen. And within this particular movie segment, we're seeing everything from starting Minishift from scratch. This would be true with OpenShift. You just change your Minishift identification to be OpenShift. So that's creating your environment. And then there's further down the page, you'll see that there's a call to Ansible Playbook to actually install the thing. And that's essentially how it all works. And within that, you can look at within OpenShift and see all of the projects. So you can see that there's lots of optionality within OpenShift itself. You have to be careful about your IP address and the port number, because when you actually download this and play with the example, which includes OpenTracing and Jaeger, you need to actually, as you can see, I did this for Centrica before. You need to make sure that the vars match the IP address and the port number. So that's kind of why you have to edit the vars. So this is just showing us that we need to make sure that they're the same. And in this case, of course, they are the same. So that's very handy. So when you actually start the deployment, then you'll actually see all of the other stuff before your very eyes after your Ansible playbook create local environment playbook.yaml file. And if we scroll down to the end, we can see the things actually sort of still waiting for certain things to happen. And in the movie, in the short movie segment, we can see that the Jaeger pod's already up. It's already got an endpoint address, and there's the project API that's up. And you can see that at the moment, the project burn down is being deployed. So this is a real DDCI pipeline with all of those tests being run as if it's a real project that somebody's really paying for, rather than a small project just to illustrate a small point. And that's because in doing this, what we wanted to do from an Estefet perspective was to share how you do this end to end and the role that OpenTracing and Jaeger can play subsequently. So if you have no code, OpenTracing and Jaeger is not of any use to you, because there is no code to instrument, there is no code to look at. But the minute that you have stuff and you're starting to deploy it, that's when this stuff comes into its own. So I'm just gonna move on to the next slide. And look at what happens when you have a bunch of microservices. How do you decompose them? Because what the temptation is often is to look at them and think, well, these three microservices share kind of the same notion of an object, and so we'll make them share the database. So often within the bounded context that you use, you'll have a shared database, and this is the classic mistake in building microservices, because what you've got at this point is schema lock-in. So the blue ones, you can't change the schema without impacting potentially any of the other blue ones, and the red ones are the same. So they're bound to the schema, which makes independence of deployability rather a nonsense, because you can't really do it very well. So the alternative is to move to an interaction-centric model where everyone has their own store, and that requires you to think a little bit more, because now you've got to think about what data am I responsible for? What data do I update versus what data I'm interested in? So for example, in our sprint example, a project is interested in everything that's within a project object. We might consider it that way. And a project may have sprints, and the sprint is also interested potentially in projects. So we can have an asynchronous notification between them so that projects look after projects and sprints look after sprints. Now, there's some challenges in doing that, which is how we synchronize things. So in order to do that synchronization, it means we've got to emit an event. So this is an event-driven architecture, and that's all well and good. But now if something goes wrong, we're forced to look at the log files of every single one of these microservices and try and figure out what went wrong if something went wrong. And that what can go wrong is many-fold. It could be that a single microservice has gone to sleep for some reason, and so it needs stimulating to come back up. It could be that there's timeout cascades as you add more scale in terms of volume through the microservices. And timeouts is a problem that I'll come back to because Jaeger really helps with that. But it's challenging. Many of us, I'm sure, have popped log files and put them on in the boardroom of a building that we're working in, and had several of our colleagues with post-it notes looking at the log files, trying to find a transactional trace in order to determine the root cause of a problem. So with data-centric architectures, it is easier to do that, but you lose an awful lot in terms of your ability to change rapidly, and so it has a negative business impact. So we have to work harder in an interaction-centric model to get this right, and that that also makes it harder to understand what's actually going on. And as we know, teams don't always stay together, and so there's also a need to be able to discover the structural properties of some distributed system in the same way that if we have a single application, we might put it through a debugger. You kind of want to do the same thing. So that loss of control is what kind of leads to chaos, because we can't really see the structural properties that need to be preserved. And that's really the fundamental aspect of Jaeger that I'm going to show you presently. And at the end of the day, as we said, you can't bring order to what you don't understand. So understanding correctness becomes a real problem and requires you to tick off and look at the log files in this way. So what we're going to do now is have a look at a little project, how we create projects in our set of microservices. So the way that we do that, I just start this bit of the movie. Oops. So the way that this works is when you click on the URI in OpenShift, is it will bring up something like this, which is the basic UI microservices Scrum application. So this has a user interface, and what we're going to do is we're going to drill down in a minute and have a look at. So I've created these already. So I'm going to look at project probably 6590 and see precisely what happens when I click on my project 6590. So I'll just wait for the movie to catch up with me. Here we go. So here's project 6590. And within that, you can see that there's a number of, I'll just go back a second and hold it there. So what we've got, if I go back, so we've got a number of, within this project 6590, we've got an active sprint, which is number 3. And within that sprint, there are a number of other sprints. So there's sprint number 3, which is active, and there's these completed sprints here, which is sprint number 1 and sprint number 2. And you can see that there's a whole bunch of stories associated with this project, which have a bunch of story points. So when we click through and have a look deeper, we can look at story 538, which is within the same project, and see that that's completed. And when we click on it, we can see precisely what tasks there are, and you can see that all of the tasks are completed, and that there's a bunch of acceptance criteria. So what we do know is that when a story is complete, it's because in part its tasks are all complete, and so that's why you get the 2 completed. So you get completed status for the story, completed status for all the tasks. So what we're going to do, just to invoke an error really, and see what happens when things go wrong with a microservice, is we're going to add a task to a story, and therefore a sprint, and therefore a project story, and that's already been completed, which you shouldn't be allowed to do because it's been completed. So when we try and add a task here, what comes back to the UI, I have to say, is not particularly helpful. And I have seen projects really do it this way, and then realize there's a problem. And the issue when there is a problem of this nature, so this is submitting the task to something that's already closed, the issue that we've got here is there was miscommunication amongst the team. And so what we get is some horrible error like this. There's a white label error page that says, hey, look, I don't know what's going on here. Got nothing to tell you, but it failed. And sometimes we see 404s and 500s. So the worst thing that we can possibly see is a status 500 just being thrown back at us in this raw form. So if this was a real project and we were doing this, we'd try and figure out, well, what happened? How did that happen? Where do we need to go and fix it? And this is just a simple case. This is just the simple case. So, oops. Let me get back here. So what I'm going to do now is have a look at how we might use Jaeger and OpenTracing to change this picture. So the beauty of OpenTracing and Jaeger, so OpenTracing is a standard. It's an interface as to how you can put tracing information into your microservices in an easy way. And if you use the Spring framework, which is already pre-instrumented, the amount of effort you have to do, quite frankly, is trivial. It's one line per microservice, which I'll show you in a minute. What you get for your money from that one line of change is the ability to see the structural properties of the microservices as they execute over time. And so you get to see, in effect, your system as if it's in a distributed debugger. And that's the power, really, of Jaeger, is that it gives you that, and it does that in a contextualized way, as we shall see. So the kind of way that we used to debug monoliths was kind of hard, but at least there weren't too many log files. But we were able to do it. This is what most of us would have gone through 10, 15 years ago. Much harder now with microservices, because now you've got lots of log files. And what you want to do is pick out the actual lines within the log files that match and therefore deliver, in effect, a business process trace. And this is the idea behind Jaeger and OpenTracing. You could use Zipkin in a similar way, but OpenTracing is the real enabler. Jaeger's a way of displaying it. So this then becomes really easy, because all those events that happen, the JMS calls, the sends and the receives in a JMS context, or calls to the database, get shown in a Jaeger trace. And we'll have a look at a real one in a minute. And that's the idea. So what we're going to do now is have a look at the actual example that we just saw. So when we saw the microservices running. So I'll just turn that off. So what we're doing here is finding the traces. So we'll find the traces here, and you'll see that there's a basic UI that has it says 10 spans. So a span is like a trace. So this is kind of like a trace through the microservice. So what we were doing, so in this instance, we're looking at actually how we created a project, so a new project. So this would be akin to a developer trying to understand what's going on, as opposed to necessarily diagnosing a problem in the first instance. And what you get is a span root, if you like, at the top. And within that, you can see calls that are made to other microservices and what happens in those microservices too. So it's very handy, and we can expand and we can contract. So when we look at the new submit in particular, so submitting a project, it kind of gets much more interesting as to how this works. So what we've got here is at the top, you can see that new project submit is there. So when you press the new project button on the UI, this is what gets in. This is what results from an instrumentation perspective. So we can see that there's that line under new project submit. Underneath that, what happens is it does a post to the project, create the new project, and within the project microservice, what it's going to do is it's not what it's going to do, it's what it's done, which is the important thing. So what it did was it issued a query to get the next project ID sequence number. It then sent a JMS send to anyone that's interested in the fact that I'm creating this new project. And then it updated the database to add the project into the database. So that's the order that things went in. So we can have a look at all of the detail of this. And what Jaeger is giving us is a contextualized view of all of this, which gets really interesting, particularly when there's errors. And equally, Jaeger's giving us the timings on all of this. So I said I'd come back to timeouts, and that's kind of how I'm going to do it. So it's kind of interesting that we can look in more detail. So we can see, for instance, the query going off here, and we can see what query is sent and what query comes, what the results of that query are. And when we look at the update, we can do the same. And with the JMS, what gets really interesting is you can see the topic that it was sent on. You see the details of that. And you can see all the details of the message that was sent. So this is saying, hey, look, I created a new project, and here's the details of the project for anyone that's interested. And this is how we use an event-driven architecture, which historically are very difficult to debug. This makes it fairly trivial to debug. But not only can we see the send, we can see the receive. So we can see the send on the one side, we can see the Sprint API then getting a message because it's subscribing to new projects, because when a project is created, it's going to, the sprint microservice will automatically create a sprint for the project. And so that's why it needs to know the project IDs. So when it gets the message, hey, I've created a new project, it says, oh, I need to create a sprint for that. So it creates a new sprint for that. And then so it cascades everything down. So you'll see the same pattern in the left-hand side of the Jaeger console here, this under span name. You'll see the same pattern repeated over and over again as all of the microservices in turn do their thing as it cascades through. Now, each one of them is independent, so things could happen and go wrong. So you have to build in additional interactions, additional sends and receives, and some state that you have to manage to handle an eventual consistency model. And you have to handle effectively rollbacks, which are compensations. So I think there's a number of papers and YouTube movies out there about what are called sagas, which is the technique that's used to handle the compensations. What that results in is even more interactions. So you get even more complicated spans. But at least with Jaeger, you can see what's going on. You can see actually under the hood, see precisely what's going on. And that really enables us to understand much more about the structural nature of the microservices. And it also allows us to do things like ensure our timeouts are correct. So we could put wait states in there to induce a timeout and see what happens. And the timeout problem really is a big one, because if all these microservices are running independently, the way that timeouts are usually put into microservices is pretty much somebody puts their finger up to the wind and sees which way the wind is blowing and says, I'll set mine at 30 seconds or 5 seconds, and the person next to them will say, well, what did you set yours at? And they'll set it the same. The problem is that under load, when you set that in that way, you'll get a cascade failure of timeouts, which are really hard to diagnose because you can't really pull everything together. But in this example with Jaeger, we can see all of that timing information. So we could do an induction of failure, we could induce the failure and see the impact in Jaeger, and therefore adjust the timeouts before we actually have to release this into full production or switch off our A/B testing or whatever it is we might be doing. So this is, you know, one of the fundamental powers behind Jaeger, in that it gives you this ability to trace through everything that happens, including asynchronous eventing using JMS sends and receives, and all for the cost of a single line of code in a microservice. So that's kind of how it works at a high level. So moving on, let's have a look at how we diagnose this error. So in the example that we had, we added a task to a sprint, to a story, to a sprint, to a project where the sprint was actually closed. It was completed. So what we're going to do now is we're going to do some fine tracing and have a look for we have to take the tags off. So we take the tags off to do an open search, and then we find, as you can see here, you can immediately see sort of center of the screen, aha, my basic UI has 2 errors against it. Interesting. Let's have a dive. Now, we're not seeing all the spans. We're only seeing the 50 limit result. There are many other transactions that occurred before this, and we can do interesting searches, which I'll show you in a minute. But let's first dive into the error and see, where did that error occur? So and the real beauty of Jaeger is it gives us effectively not just a distributed debugger view, but contextualized logging. So we don't have to worry about which log we're looking at. It comes as part of the context of the microservices that we look at. So when we drill into, as you can see here, we've got our basic UI calling the task API to create the task, which it's not allowed to do. And we can see a little icon that suggests there's an error, which is the little exclamation circle. So when we click into these, we can see actually what happened. So rather than us look at the basic UI log file and then look at another log file and another log file until we get to the end of the chain, we can just see it straight away. So it saves huge amounts of time. And you'll see here that it's crying out at us. You can see the message here, cannot add tasks to completed story. And underneath, you've actually got the log file stat trace that's situated within the span, which makes it really easy to debug things. And we can look up and down that and see what should have happened. So this is really the huge benefit to a developer when they're actually developing stuff and something goes wrong, that you're able to use Jaeger effectively as a distributed debugger that allows you to rectify quite complex problems much faster than you would otherwise be able to do. And in Estefet, this has now become de rigueur. This is what we do when we do microservices. So we don't write microservices without OpenTracing and without the ability to then have those OpenTracing events reported back through Jaeger. So all our developers today use this, and this has had a major impact on their lives, makes it much more pleasant. So if I sort of speed this up a bit, we'll have a look and see how we can change the number of traces we see, so the number of spans we see, by changing it from the last hour to the last 12 hours or whatever, however we want to do it. Whoops, my apologies. I'll do that again. So yeah, so we can change the and we can change I'll go back slightly. Right, so the key here is that the error tag, there's an error tag that's set to true. This is done automatically within the Spring framework. You can have other tags too, so you don't just have to have the error tag. That's kind of like a built-in tag. But the beauty is that you can find all of the traces where error is true, and that's under the tags bit up here where it says error : true. Now I might have another tag that says MIFID, or I might have another tag that says GDPR, and I can add my own what are called baggage tags to my transactions. You have to be careful about doing that because it does propagate across the distributed landscape, and that will enable me to search more in a more sophisticated way, perhaps for all MIFID transactions, such that they have an error and they're also GDPR transactions. And that would allow me to have a look at different scenarios simply by using OpenTracing and Jaeger, which is a huge amount of power and a huge amount of order from the chaos of the microservices that would have existed prior. So the sort of changes that you've got to do to implement this are really, really, really simple. I cannot emphasize how simple it is to do the first step. The real skill comes in understanding how to use baggage tags in an effective way, and the real skill comes from how you put your microservices together in the first place, so that you can get the best kind of scaling dynamics and the best independence of deployability, and therefore the better velocity to incorporate change over time. But to do it in Spring, so if you were just using Spring, there's a single change, right? So you can see the change in front of you in the middle of the screen on line 24. There's pretty much a single change. So you could imagine certainly writing a script that would go through all of your existing Spring-based microservices and adding this to it, and then deploying it with OpenTracing and Jaeger. But as I say, that's the first step, and you should definitely do that. But the second step is really to then sit back and think about how else can I use this, because there's way more power in using OpenTracing and Jaeger than simply as a distributed debugger, and we'll come to that in a second. And here's another. So you've got the basic UI microservice, and you've got the microservices API board as well. So there is only one line really that changes, which is on line 25 in both instances. So it's just the configuration telling it it's the sprint board or it's the basic UI. So I'm just going between them. So it's pretty simple. So the catches. So this is what a span looks like. So we saw it as lines stacked on top, one on top of the other, but actually there's a root span. So the basic UI has the root span, and then there may be other spans of the basic UI. So each microservice may induce a new span. So span B and span D are children of A, whereas D of course is a grandchild of A and a child of B. Span C, which is a child of A, has a span E that's a grandchild of A, but specifically it has a followed by relationship between span F, span G, span H. So it means in a single microservice, I can separate the spans. So there's more engineering to do if you want to get the benefits of Jaeger. and there's some skill to be brought to the table in terms of how you separate your spans out per microservice, and that's something that we do at Estefet all the time. So this is kind of how we might see that same span if it were portrayed into, or if we saw it rendered in Jaeger itself. So you've got span A, which is the longest, and then you've got span B, span C, which are, if you like, peers of each other. Span D's inside span B, and then you've got E, F, G, and H. So this is how the spans might look. The key thing, what's actually in a span, what's the actual key data that allows us to make the causal links between things is it's a simple list, actually. It's an operation name, it's a start timestamp and a finish timestamp. That's how you get the timings. It's a set of 0 or more key value span tags and logs. So that's where the log stuff comes from. And a span context. And then you might have 0 or more causally related spans and then plus baggage tags. So plus baggage tags onto that. But effectively, the key value pairs is the 4th attribute in that list. That's where error becomes a built-in. So that happens automatically if you're using Spring. So when we look at baggage tags as key value pairs, so if I add a baggage tag somewhere, I might see a key value pair added to the span of C, which gets propagated to E and propagated to F, G, and H. So this is why when you start adding baggage tags to your OpenTracing world, you have to be conscious of that. If you were to add a gigabyte value, that's probably not a good idea because that's going to propagate through your network. I think your network will go very slowly. So use it very carefully and think very carefully about why it is you would want to use the baggage tags. We have found use for it, certainly for things like identifying MiFID transactions, identifying GDPR transactions, and things like that. So it has a relationship, oddly enough, to the world of compliance. There's many opportunities in this world of OpenTracing and Jaeger, and we're at Estefet, we're working quite a lot with Red Hat and the Jaeger team within Red Hat that Gary Brown leads, and we're working with a bunch of academics to do some really cool stuff. So some of the stuff behind OpenTracing and Jaeger to some extent, came from a paper that received an ACM Best Paper of the Last Decade award in January. So it's usually about 10 years when something comes into production. So this is about right from the way that generally academic excellence has reached business in our world of business. So it's about that 10 years now. There are many opportunities. Some of them, it's not just distributed monitoring for developers. So understanding legacy. So we can consider, given that we know what's needed for a span, what the attributes are, we could consider thinking of a legacy system that's not been instrumented at all in terms of its log files, and therefore unpick it and turn it into OpenTracing events and see how it looks in Jaeger. Might be useful. Certainly it would provide us with enough upfront knowledge to at least understand some of the key transactions. Equally, process lineage for MiFID II. So understanding that a transaction is truly compliant. So if you imagine your baggage tags for MiFID II, all having a tag that says MiFID II, and then within the MiFID II at the end of it, if we add to the end of the word MiFID II, additional aspects to a particular business process that we're interested in, if you add that as part of your development story, then you become automated in terms of how you can show compliance to MiFID II. Or the same would be true of any kind of compliance process that you want to put there. And that gives us a whole bunch of other things that we can potentially do with OpenTracing and with Jaeger that thus far have yet to be turned into true products. But it is something that we're working on with the Jaeger team and with the academic institutions that we've been working with over the last couple of years. So there's many opportunities. So I kind of just want to summarize as to what we've been talking about. So hopefully I've given you some guidelines as to how to build good microservices. There's a lot out there on Google and on YouTube that tell you how to do bounded context. They tell you how to that you should use event-based microservices and use eventual consistency models, but they don't generally give you a fully fledged working example. And that was something that we very much wanted to share with the community at large. And we wanted to provide an easy way to understand how all that works in practice, not just slideware, but an actual demo that you could pick up, put on your box and run today if you wished. And equally, we wanted to be able to have you run it on a single box, or in an Amazon or an Azure environment, doesn't matter. As long as OpenShift is the consolidating platform as a service, it all works. And we wanted to also to give you a view as to how OpenTracing and Jaeger really helps to diagnose problems, and show you some additional use cases that might be of value. So I hope we've covered all of that. I do want to say thank you to Diane for organising this. I want to say thank you to Gary Brown for continuing to work with us after all these years. And I want to say thank you in particular to Dennis Williams, who's been my right-hand man on putting this presentation and the demo together. Please come to our GitHub. If you want to contact me, it's very easy. It's steve.ross-talbot@estafet.com. We'd be very interested to talk to you and see if there's anything that we can do to help you. Thanks very much for listening.
Well, Steve, thank you very much for a wonderful presentation and really practical, good advice on using OpenTracing and Jaeger. I love the part about debugging with OpenTracing, and it's just that it's become sort of a de facto way of things working at Estefet, and I think a lot of other places will start using it as well. I encourage everybody to take a look at the GitHub repo that he's got down there, as well as take a look at the Jaeger repo and the information around Jaeger as well. There's a lot of great work that's going on by lots of different companies, and Gary Brown is, one of the lead people from Red Hat working on it. But there's a good crew of folks that are helping make Jaeger sort of the de facto standard, which is pretty wonderful. So if you have questions, now would be the time to ask them. I'm not seeing any in the chat, however. So if not, I will post this video up on YouTube shortly, along with the slides, and throw in a few reference links as well, including the GitHub here for Estafet's wonderful demo. And I will let everybody get on with their days. So thanks again, Steve, and I look forward to seeing you in person at the upcoming London gathering on January 30th in 2019, when we have our London, UK-based regional OpenShift Commons gathering. I'm hoping Gary was on stage last time on one of the panels, but I'd like to showcase some more of that event too.
We may well have some even cooler stuff to show people by that time. I'm pretty sure we will.
Awesome. Well, thank you very much.
Thank you.